long. So we shall solve some few examples. So we'll use the concepts ambazo tumetoka kuderive the formulas za open pipe, closed pipe at one end and the strings. So maswali haya yafuatayo. So before we start the questions, let us test our understanding on harmonics and overtones by completing the table below. So complete the table below matching the number of harmonic and its corresponding number of overtone. Okay, so we know that this is a material, either strings, open pipes or closed pipe, and the row, the first row tells us this is the column of harmonic, this is the column of the value of n, okay, value of n, and which are harmonics, of course, and this is the value of overtone, kama ni 7th, 1st, 2nd, or etc. So you are having a string which is having n is equal to 2. Okay, n is equal to 2, we know it is second harmonic. We know it is second harmonic. This is second harmonic. Second harmonic. Okay, and being second harmonic, it is the first overtone. Okay, it is the first overtone because n is kuanzia n is equal to 2 kwenda mbele hizo ni overtones. So n is equal to 2 is the first overtone. In the open pipes, you are having the 7th overtone. You know the open pipes in kama strings is na follow n is equal to 1, 2, 3, etc. So having the 7th overtone means you are having n is equal to 8. Okay, n is equal to 8 because the first one is always the fundamental. The overtones start from n is equal to 2. So mpaka 7th unakuta ni n is equal to 8. Okay, because n is equal to 1 ni fundamental. So kuanzia n is equal to 2, that's where we count the harmonic. So n is equal to 2, n is equal to 3, ukihesabu mpaka n is equal to 8 ndio utapata the 7th overtone. While the harmonic na yenyewe inakuwa ni 8. For closed pipe ina follow sequence ya n is equal to 1, n is equal to 3, n is equal to 5, n is equal to 7, enda kwa mbili mbili namna hiyo. So having the 5th harmonic
in the closed pipe, we don't have second harmonics, we don't have 4th harmonic, we don't have even harmonics. So huwezi ukasikia mtu kwenye closed pipe anaongelea second harmonic, huwezi ukasikia kwenye closed pipe mtu anaongelea 4th harmonic. So tunaposema 5th harmonic, it means n is equal to 5. Okay, 5th harmonic means n is equal to 5, while for the overtone kwa sababu inakuwa ni 1, 3, 5, 7 na 9. So ukiangalia 5th overtone, I mean 5th harmonic ni hapa n is equal to 5 because hatuna 2, hatuna 4, hatuna 6, hatuna 8 etc. Even harmonic zote hazipo. So 5th harmonic inakuwa n is equal to 5. So when n is equal to 5 tunaangalia overtone ngapi? Hii ni fundamental. Overtone zinaanzia kwenye anything above the fundamental. So we have the first overtone and we have the second overtone. So 5th harmonic, which is n is equal to 5, ni second overtone. Just like that.
So this table is actually a warm-up to try and test kama you really understand the relation between the harmonics, the overtones, and the values of n. Okay, so those which are odd we call them odd harmonics, those which are even we call them even harmonics. So we know for a closed pipe there is no even harmonics, all harmonics are odd, while for open pipes and strings they give both odd and even harmonics. So for instance, we solve this question. The third overtone produced by a vibrating string which is 2 meters long is 1200 Hz. What is the frequency of the lower overtones and of the fundamental? And what is the velocity of propagation? So we know from our formula of vibrating string is like that of open pipes. We know that L is equal to N wavelength over 2, right? Yes. So speaking of a string that is 2 meters long, okay, and it is the third overtone, it means n is equal to 4. Okay, it is the third overtone, that means it is n is equal to 4. So you have 2 here, you have 4 here, so you can get the wavelength from there. Okay, you have you can get the wavelength from there of 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 that third overtone. But the question specifically does not ask about third overtone. The question asks that what are the frequencies of the lower overtones and of the fundamental. The lower overtones manake ni second na first overtone ambao ni n is equal to 2 na n is equal to 3. Okay, tukiangalia kwa ya kwanza ambayo tutasema third overtone is the fourth harmonic. Okay, yeah. So having the frequency of 1200 hertz, 2 meters long, for the third overtone ni 1200 hertz. So if you want to get the velocity, if you want to get the velocity from here, we know that from velocity of a vibrating string ni sawasawa na frequency times the wavelength, which is the wavelength is twice the length over n. Okay, so we know it is fourth harmonic, so n is equal to 4. N is equal to 4, and we know the length is 2. Okay, so if you take 2 times 2, I hope this haija kuchanganya, instead of L and N ndo hizi 2 and 4. So this means 2 times 2 divided by 4. Ukidivide hapo utapata velocity sawa na frequency, ambapo frequency ya n is equal to 4 tulikuwa tumepewa 1200. So we have V is equal to 1200 meters per second. So tumesha solve what is the velocity of propagation. But what are the frequencies in the lower overtones? Tumesha sema, tunakumbuka kwamba V, general formula yetu ya V kutoka kwenye formula yetu ambayo ilikuwa inatuambia ni sawa sana F times 2L over N. Okay, times 2L over N. Tunapata frequency that corresponds to a particular wavelength for that harmonic. So if tumeambiwa kuanzia fundamental, tumeambiwa the lower overtones na fundamental. For the third overtone, it means tunatakiwa tafute lower overtones, second overtone, first overtone plus the fundamental, which means both three are covered in the question. Fundamental, the first overtone which is n is equal to 2, and the second overtone which is n is equal to 3. So tukianza na fundamental, we can put our expression in terms of frequency, that Fn ni sawa na V n En ikienda huku divided by 2L. So the frequency 1 which is fundamental ni sawa na velocity ambayo ni 1200 tumeshasema, times n for frequency 1, n is equal to 1, the fundamental, times okay, divide, there is nothing else to divide 2 times L, the length is 2. So ukichukua 1200 divide by 4 unakuja kupata the answer is 300 hertz. Ndio alichofanya yeye hapa, kupata jibu 300 hertz. Nitakuja kuambia kwa yeye amefanyaje hapo, but nimependa tuanze na hii kwanza kabla tujaenda kwa njia aliyofanyia. So similarly for the first overtone, it means n is equal to 2. First overtone, n is equal to 2. So n is equal to frequency 2, which is the first overtone, ni sawa na V 1200 times n, the first overtone is n is equal to 2, the second harmonic, divide by 2 times length 3, 2. So 2 na 2 zina cancel, unapata jibu ni 600 hertz. As you can see hapa napata 600 hertz. So ukimalizia na the second harmonic au n is equal to 3, unapata I mean the third harmonic, n is equal to 3, or the second overtone, unapata the final, which is 900. It is 900 hertz. So this is how we do it, but basically alichofanya huyu ni kwamba amechukua the concept. You remember I told you the other time kwamba if we are having the general equation ya frequency, okay, from here kwamba ni v times n divided by 2 times L. So we know that if f is equal to 1, the fundamental frequency, if f is equal to 1, inakuwa ni v L divided by 2, n is equal to 1. So when n is equal to 2, tunakuwa na 2 times v divided by 2L. When n is equal to 3, tunakuwa na 3 divided by times v over 2L. n is equal to 4, tunakuwa na 4 times v over 2L. So you can see v over 2L repeats itself all the time. v over 2L repeats itself all the time, and v over 2L ndio ilikuwa frequency ya fundamental, sababu fundamental when n is equal to 1 unapata v over 2L. So generally the general formula Fn ni sawa sana n times fundamental frequency. So the same if you are having Fn, amekupa Fn ni 1200 where n is equal to 4, kwa sababu ni third overtone, n is equal to 4. So is equal to 4 times fundamental frequency. So to get the fundamental frequency ni 1200 divided by 4, ndio alichofanya hapa. 1200 divided by 4 kapata the first harmonic or the fundamental. So similarly use the same to calculate the other ambayo umeulizwa. Kwa mfano the second overtone which is n is equal to 2, unaweka tu hapa n is equal to 2, hapo unaweka 2. The fundamental frequency ambayo tumepata 300 na 2 mara 300 ndio 600. So the second overtone which is n is equal to 3, second overtone which is n is equal to 3, unachukua 3 times fundamental frequency which is 300, unapata 900, just like that. So that is how amefanya hiyo. So another question, you have a 160 cm long string which has two adjacent resonances at frequency ya 85 na 102. Wakisema resonance, I believe you remember, ni vitu ambavyo vinakuwa vina vibrate at the same properties, okay, zinakuwa resonant. Moja ina vibrate the other as the result of others, the resonance, okay, they vibrate finally together under their natural frequency, they vibrate under their natural frequencies, lakini moja ndio imemsababisha mwingine afanye hiyo oscillation. So okay, our interest is not about the resonance, but coming back to the question, 160 cm long string has two adjacent resonances at frequency 85 na nyingine ni 102. What is the fundamental frequency of the string? Okay, so remember these are adjacent. It means ikitoka n is equal to hicho kinachosababisha 85, inayofuata kunayosababisha 102 ni n plus 1. Okay, ndio maana wamesema ni adjacent. So if this is n, this is n plus 1. So we know for a string we know frequency ni sawa sana v n over 2 L, as we have said earlier. So if for the first Fn, sawa, which let us say ni tumesema n ni 85, is equal to v times n divided by 2 times length ya string. Okay, length ya string tumeambiwa ni 160, so it is 1.6 meters, and f ya n plus 1 which is equal to 1 or 2 is equal to, kumbuka always the lowest frequency has the lowest n. So the higher you increase the number of n, the higher the frequency. So it is correct to assume this is n plus 1. Okay, yeah. So v times n divided by, so this is an n plus 1, this is n plus 1, divided by 2 times length ya string ni 1.6. Okay, so if you divide these two equations utapata 85 over 102. Ukidivide 2 times 1.6 ta cancel na 2.1, 2 times 1.6, v na v zita cancel, so utabaki na n divided by n plus 1. So from there you can solve for n. Solving for n, you will get the answer as what amepata hapa, n is equal to 5. N is equal to 5 na n plus 1 is equal to 6. So for 85 inakuwa ni n is equal to 5 na for 102 n is equal to 6. So the question though asked what is the fundamental frequency of the string. So coming back to the equation, so we know kama tuna 85 tumeshaitafutia value yake ya n. Okay, now we know the length of the string ni 1.6, then tunaweza tukapata velocity ya string. So we know velocity ni sawa sana frequency 85 times twice times 1.6 meters divide by n. For that case n is equal to 5 kwa sababu ya 85 hertz, n yake ilikuwa is equal to 5. So from there you can solve for v na utapata v ni 54.4 meters per second. Okay, sio lazima usolve in sequence ambayo amekuuliza anza na hii, no, not necessary. As you can see hapa tumeanza kusolve for speed of the waves. Okay, speed of the waves. So if we want to solve the fundamental, we know fundamental n is equal to 1. So if we are having the speed of the wave and we are having the length of the string, Mungu atupe nini? Imeshaisha. So v tulio solve 54.4 meters per second. For fundamental n is equal to 1, tunaweka n is equal to 1 divided by 2 times 1.2 times 1.6. So we'll see our fundamental frequency being 17 hertz. So the final part is asking what is the length of a segment of the 85 hertz resonance. Ukiambiwa length of segment wanamaanisha katika ule mchoro wako kama huu. Sawa? So as you can see, this is the first segment, second na third. So they want the length of this segment. So you know any segment katika string, any segment katika string is equal to half of the wavelength. Kwa sababu for any segment, hii segment ni half of the whole wave. Hii segment ni half, if you remember. Hii segment ni half of the whole wave. If you remember, it's the reason I showed this. So if you want this segment, ni quarter plus a quarter inakuwa ni half. So what we are required to do, we know that if that is half, it means it is half of the wavelength. Kwa sababu length ya segment kutoka hapo mpaka hapo ni sawa na half ya wavelength. So it means we tutafute wavelength, tutafute half yake. So we know tumeambiwa katika hiyo ya 85 hertz ambayo n is equal to 5, but we know where can we get the wavelength katika ile general formula ya n, wavelength divided by 2. So we know the wavelength ni sawa na L ambao for that case ni 1.6. Tumeambiwa string ni 1.6 meters long times 2. Sasa 2 inaenda kule divide by n. For tumeulizwa 85 hertz resonance, so n is equal to 5. N is equal to 5, then tutapata wavelength. So tunatafuta length ya segment ambayo ni half the wavelength, so times a half. So 2 na 2 zina cancel, you can see clearly kwamba hiyo ni inakuwa ni 3 0.32 meters. Okay, or in other words inakuwa 32 centimeters as they have shown hapo. However, ukiangalia solution ambazo huyu ameandika hapa, ametumia principles za kucheza ile na kwamba hii times hii, how you multiply them kutoka kwenye fundamental, na recommend ufanye kwa namna hii. I don't recommend really ufanye kwa namna hii. Ningependa ufanye kwa namna hii ili uzoee hizi concept. However, still you can do kwa jinsi alivyokuwa anafanya hapa kwa kutumia the general equations, kwamba f ya frequency ya any harmonic ni sawa na n times fundamental frequency. So haya maswali ya what is the fundamental frequency yanakuwa ni marahisi zaidi, kwa sababu unavyosema fn ni sawa na n times frequency ya fundamental. So you having fn ambao ni value ya ngapi? Fn ambao value yake ni 85, sawa, is equal to n yake ni 5. So what is the fundamental frequency? So simply from here you can get the answer, sababu unachukua 85 divide by 5. Okay, 85 divide by 5 and you get your answers 17, ambayo very easily you get your fundamental frequency bila kuzunguka sana like the way we were doing. But otherwise always are correct, stick to which ambao unaona wewe ni rahisi. I recommend ufanye hivi ili uzoe kufanya maswali. So an organ pipe which is 1 feet long is open at both ends. If the velocity of sound is 1100 feet per second, what is the frequency of the fundamental and of the first two overtones? Okay, it is open at both ends, ni kama strings. So I think by now you should be knowing how to do them. The only difference ni namna zitakavyoapia kwenye michoro kama hivi, but everything else ni kama ni kwenye string. So if you could try on your own to test yourself kama umeelewa, sawa, exactly kama tulivyofanya kwenye string, exactly kama tulivyofanya huku mwanzo, is the same na kama ukiambiwa an organ pipe which is open at both ends. So try that and let us see kama unaweza kufanya mwenyewe. There is no problem with conversion, as you can see hapa ni feet per second na hapa length imepoa in feet, so zitaji cancel. Otherwise to be safe you can convert them kwenye SI units. So ukifanya ukaweza, nitaamini paka sasa hivi utakuwa umeshanielewa. So we are having a sounding tuning fork whose frequency is 256 is held over an empty source measuring cylinder. A sound is faint, but if you just add the right amount of water is poured into the cylinder, it becomes loud. It means sasa imeshafikia frequency kama ile ya tuning fork, kwa sababu hapo unakuwa unatafuta resonant length. Kwa unakuwa unapiga pale, sound ni faint, sound inakuwa ni faint mpaka utakapojaza ile bika katika right amount, then ile bika na yenyewe itaanza kutoa sound kama ya ile tuning fork, kwa inakuwa kwenye resonance. If the optimal amount of water produces an air column of length 0.31 meters, what is the speed of sound in air to a first approximation? So we know kwamba ukiweka kwenye bika, sawa, you are having a beaker, hii ni kama pipe closed at one end, then you are filling water. You are having a tuning fork at this point, okay, kwa inakuwa ina emit sound ambayo inakuwa resonant na hii hapa. So they say that if the optimal amount of water produces an air column of length, what resonates ni air column. Okay, so unapokuwa unaadi maji unazidi kupunguza hii air column, so you have a minimum length at 0.31 meters. So what is the speed of sound in air? So we know the general equation here, closed at one end, the L is equal to N over 4, but we know kwamba N inatoka ni 1, 3, 5, 7 na kuendelea kama the way it is written hapa pembeni. So from here we know velocity ni sawa na frequency times 4L divided by N. Okay, So if the optimal amount of water, it means the lowest frequency ambayo inaweza ikatumaki hapo, we are speaking of the fundamentals. So n being 1, you are having the frequency which resonates kama ya saw tuning fork, which is 256. Okay, 256, and you are having 4 and the length is 0.31. So from here you can simply get the velocity. So you take the frequency 256, so you can try and see what we will get, times the length, which is 0. Divided by n, which is of course 1, so you get the velocity is around 317.44 meters per second. Okay, yeah, so that's how we do it. Again, the loudest sound will be heard at resonance when frequency of vibration of air column is in the cylinder is the same as that of the tuning fork. Okay, the loudest sound will be heard at resonance. You remember, as I said, sound inakuwa faint mpaka itakapofikia resonance when the frequency of vibration of air column is so hii ni explanation kwa jinsi alivyokuwa anafanya yeye. So alivyofanya yeye, the answer is 317. So we're having a vertically suspended 200 centimeter length of a string is given a tension equal to the weight of 800 grams mass. The string is found to resonate in 3 segments. Okay, the string is found to resonate in 3 segments to a frequency of 480. So you can know that relation ya segments na string, as you remember, for the fundamental we are having that. Okay, as I said, the higher you go, the more you add the nodes. So you had 2 nodes, you are adding 1 more node. So n is equal to 2, you have 2 segments. So n is equal to 3, you have 3 segments. So anavyokuambia it is found to resonate in 3 segments, it means n is equal to 3, which is third harmonic. Because it is a string, inakuwa ni the same as number of harmonic. So the string is found to resonate in 3 segments to a frequency of 480. What is the mass per unit length of the string? So hili swali lina integrate knowledge ya vile ambavyo niliwafundisha mwanzo, variation au effect ya temperature mwanzo kabisa. Some effect of the environment, I mean not temperature, effect of the environment. You remember I said for a stretched string, V ni sawasawa na square root ya tension divided by mass, if you can recall up. For a stretched string or spring, for that case umeambiwa imekuwa hanged na kuna mass imening'inizwa, so we expect the string iwe stretched. So for a stretched string or spring like that with that mass hang, inakuwa ni sawasawa na square root ya T divided by mass per unit length. So the question tells us what is the mass per unit length. So we know that tukipata velocity kwa vile tuna tension tunaweza. So if V is equal to square root ya tension divided by mass per unit length. So we know tutakapopata tu velocity tutapata mass per unit length. Sababu tension tumeshapewa is equal to the weight, ambayo weight ni mass times gravity. So how do we find the velocity? Because it is third harmonic for a string, we know V is equal to 2L over N times frequency. Okay, so having 2 times length ya string tumeambiwa ni 200 cm, which is 2 meters, times frequency tumeambiwa ni 480 divided by N ambayo ni third harmonic, as we have said. So solving for that, we get the velocity as 640 meters per second. So coming back to our formula, if we square this, we know that V squared ni sawasawa na T divided by mass per unit length. So mass per unit length inakuwa ni sawasawa na ni T. Okay, you take that there, bring V square here, divided by V squared. So the tension ni sawasawa na mass times gravity. So we have the mass as 800 times gravity ya 9.8 divided by the velocity squared. Velocity tulipata ni 640 squared. 640 square. So you can see it's what they have written here. Remember this was 800 grams, so you convert it into kilograms. So here you multiply times 10 power negative 3. The maana hapa ni 0.8. That's how we do it, and we get our mass per unit length like that.